Hello everyone, this is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University, Surampalem. Today we would like to discuss about the concept JK flip-flop. So coming to the learning outcome, at the end of this lecture, students will be able to understand, analyze and design sequential circuits using JK flip-flops for state control and counting applications. So these are the types of flip-flops. So we already previously discussed about the SR flip-flop and now this is JK flip-flop. Coming to the JK flip-flop, there is no any official full form of JK. So that is why we call this one as a JK flip-flop. So a JK flip-flop is an improved version of the SR flip-flop that eliminates the invalid condition. So if we consider this is a SR flip-flop truth table or characteristic table. Now in this particular last row, if you consider S is equal to 1, R is equal to 1, that means set condition is equal to 1 and reset condition is equal to 1. In SR flip-flop, the whatever the next state is, that is invalid condition. So in order to avoid or in order to eliminate this invalid condition, we are using this JK flip-flop. So now a JK flip-flop is an improved version of the SR flip-flop that eliminates the invalid condition. It has two, that means inputs, that is J and K. So likewise S and R, here J and K are the inputs and a clock signal is also there and it can hold reset, set and finally the toggle condition, its state. Now this is a simple block diagram of this particular JK flip-flop. So JK flip-flop contains here J and K are the inputs and clock is also one of the input and Q bar are the outputs. And here the angle represents the, this is a edge triggered, that means that is a clock signal, edge triggered clock signal, that means either positive edge or negative edge it represents, that means this is a flip-flop. If it is edge triggered means that is a flip-flop. Now coming to, this is the circuit diagram of the JK flip-flop which contains 4 NAND gates. This is a simple construction, 4 NAND gates and these two output is given to this NAND gate and this output is given to this NAND gate and J is directly given to this NAND gate as an input and K is given to this NAND gate as a input. Here J and K are satisfied. And finally clock signal is also one of the input terminal for these two NAND gates and the output here, whatever the output, that is Q bar, that is given to, this is not a junction, this is a just loop form and this is bypassed and it is given to one of the input, that is J, and here Q is also connected, here this is also not a junction, this is bypass. This output is given to input of one of this NAND gate. That means here Q and Q bar is also, that Q and Q bar are the outputs and that is given as an input to the, again one is for J and other is for K NAND gates. So that means, so outputs is given to the inputs, that means outputs are feedback to the inputs. So it forms a loop. And here as usual, this is a simple SR latch, SR flip-flop. So that means JK connection, the extra circuit is connected to the SR flip-flop. That means finally we will get the JK flip-flop. So here toggle on lead edge of clock signal, that means we are using the clock signal and the two, that is the toggling condition. And RS flip-flop, here SR flip-flop or RS flip-flop, this is the SR flip-flop. So here this is the characteristic table, we call this one as a characteristic table, that means just like truth table. So whenever the clock signal is not there, that means clock signal is not there, simply it follows the previous states, the output follows the previous state. That means here now the clock signal, whenever the clock signal is high, then only we have to consider the outputs. For particular inputs, we have to consider the outputs. So here J and K are the inputs. Again J and K are the inputs, that means two inputs are there. Definitely we will get the 4 combinations. So these are the 4 combinations, 0 0, 0 1, 1 0 and 1 1. Now for this all 4 combinations the clock signal is enabled, that means clock signal is 1. Now Q is our output, Q bar is just inverted of Q. Now here the Q is nothing but, so most of the time, so if both inputs are 0 0, simply the Q, whatever the Q is the output, that simply the previous output, that means previous output means whatever the Q, previous Q, now the present q also q. So that is the previous version. But while coming to, that means here we can call that one as a no change in state. So there is no change. That means it will, output will follow, simply follows the input previous state. Now coming to 0 1 condition, so whatever the j is there, that means j is 0. Now q is also 0. We have to remember like this. So q is also 0. Likewise, reset condition. This is a simple reset condition that reset to 0 because the output is 0. That is why, that is output is q is 0. Now coming to this one, j is equal to 1 and k is equal to 1 0. So 1 0 combination. So q is equal to 1. Simply it follows the j. Again q follows the j, and this is just like a set condition. That means set q to 1. And finally, this is an invalid condition in the SR flip-flop. Now we have to eliminate this invalid condition. So for both inputs are high, that means jk inputs are high, that means 1 1. Now we can define this combination as output like toggling condition. Toggling condition means if q is there, the output is q bar, and q bar is there, the output is q. So likewise, we can predict the what we call this toggle condition. That means at least we can get the output here, but it is not possible in the SR flip-flop. So it is possible in the JK flip-flop. So we can get the toggling condition for both inputs, that is j is equal to 1 and k is equal to 1. So we can simply get the output, that is nothing but the toggling condition. Now, so these are the 4 cases again. So that is defined j is equal to 0 and k is equal to 0. Finally, flip-flop does not change its state and q retains its previous value, that we call it as a hold state. And if case 2 j is equal to 0 and k is equal to 1, the flip-flop just resets. That means q is equal to 0 and q bar is equal to quite opposite, that is 1. And case 3, j is equal to 1 condition and k is equal to 0. So q simply follows the j. So j is equal to 1, that is why q is equal to 1 and q bar is equal to 0. And finally, our condition, this is simply 1 1 condition. So invalid condition in SR. Now we are simply define that condition. So j is equal to 1 and k is equal to 1. Then q becomes the complement of its previous value. That is why we call this one as a q bar, and becomes the complement of q. That means q becomes the q bar and q bar becomes the q. That is simply quite opposite. That is q becomes q bar and q bar becomes q. That we call it as a toggling condition. So these are the key points. So unlike SR flip-flop, so the invalid condition is eliminated here. So in this condition, we can eliminate. Now when both inputs are 1, the output toggles instead of becoming undefined. So we can get the output, not undefined. We can get the output here. Now this is a simple circuit diagram of this particular JK flip-flop. Now coming to the characteristic table, so here the inputs are j and k, but while coming to qn, that is if q is 0 one time and qn is 1 at one time, that means for both conditions. So coming to the characteristic table, here the inputs, here jk are the inputs, but coming to the output qn is also one of, if we consider this one as the input, that means now the inputs are 3. Again we can get the total 8 combinations. So total 8 combinations means simply we can follow the binary 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So it represents the binary. Now we have to follow the output. So output, that is nothing but qn plus 1, that is the present state. We call that one as the present state or next state. Now this is 0. That means if the inputs are both 0 0, that means 0 0 combination. So simply the output is nothing but the hold condition, whatever the previous outputs that is there. So this is now we are getting. So same 0 1 combination. But while coming to 0 1 combination, in this particular 0 1 combination, if qn is equal to 0, that qn plus 1 is 0. But while coming to this qn is equal to 1, the output qn plus 1 is 0. Here 1 0 1 0 combination, again for 0 1, irrespective of this qn, the qn plus 1 is both 1. And for 1 1 condition, that is just like toggling condition, we call, if 0 is there, 1 condition, 1 will be there, and 0 we will get. That means simply quite opposite. Q is there, q bar is there, q. So likewise 0 is there, 1 is there, 0. So likewise we can construct this characteristic table. Now coming to characteristic equation, so this is the characteristic equation. So this we will get with the help of the K maps. So we can use this K maps with the help of, see, if we consider the last column, so now, so this is a 8 box K map. So 0 0 0 0 0 1 0 1 0 1 1 0 1 0. So 0 1 3 2 representation and 4 5 7 6. So now here 1 is there, that means the corresponding input is 1, that is why here 1 we have to place, and here 4 is there, that is why we are placing 1 here, and 5 here, that represent 5, 1 is there, here we have to place 1 here, and finally 6 is there, 6, this is the 6 representation, 1 1 0 representation, we have to place 1 in this particular box. Now we have to follow the K map. K map means grouping of ones here. So we can group these 2 ones, so that is why this red mark indicates these 2 groups, 2 ones, 1 group, and here we can group this one and this one. So we can group these 2 ones. So now we can give the equation. So for that particular equation, if we group these 2 ones, then J is common. So J, and here K bar and K. K bar and KB is switching. K bar and K is switching. That means we can remove the K term, and Qn bar is the common. So that is why here this is Qn bar. So J Qn bar plus next this 2 ones we are forming grouping like. So J is switching from J bar to J. So we can eliminate J term, and the term is K bar Qn. So this is K bar and Qn. So finally whatever the characteristic equation is, after getting the output of this particular K map, so Qn plus 1 is equal to Qn bar into J plus Qn into K bar. So this is the characteristic equation for this particular JK flip-flop. Now coming to the advantages of the JK flip-flop, so here no invalid state. So likewise previously in SR inputs, that is both are 1 1, so there the invalid condition is there, but here we are eliminating that invalid condition. Definitely we will get the output here, the toggling condition. So unlike SR, so JK is equal to 1 condition, so valid output we will get, that is toggling. Now versatile operation, so it can perform all operations like hold, set, reset, and finally the toggle condition. And useful for counters, so most of the counter circuits we are using this JK flip-flops. So ideal for designing synchronous and asynchronous counters. So most of the time we will use the JK flip-flop in counters. And flexible design, this can be converted into D and T flip-flops also. So with the help of JK we can convert into D and T flip-flops. And reliable in sequential circuits, so most of the time widely used in clocked digital systems. So these are the advantages. While coming to the disadvantages, so here one of the drawback is the race around condition. So here in race around condition, if J is equal to 1 and K is equal to 1 and the clock pulse is also high, that means all the 3 inputs are high. Now if these 3 inputs are high for a long time, so output may toggle continuously. So that means if we expect Q, it will give Q bar. If we expect Q bar, it will give Q. That means continuously it is toggling. So at the end of the signal, that means if we change the signal or clock pulse is 0 or clock pulse is other input, so definitely we cannot predict the output, either that is 0 or 1. So this is the drawback. So that we call it as a race around condition. So most of the time clock pulse, all these inputs are high for a long time, definitely this race around condition will arise. And complex design because of the feedback circuit. So output is given to the input, so that is why this is forms a loop, so that we call it as a feedback. That is why, so it is somewhat complex design. And so higher power consumption, definitely more switching activities compared to simpler flip-flops. So previously we discussed about D flip-flop and SR flip-flop, but here loop is there. That means output is given to the input. Definitely it will take more power consumption and requires proper clocking. So needs edge triggered or master slave configuration to avoid errors. So these JK flip-flops are used in master slave design also. So one input is given to, that means clock is given to master and clock bar is given to slave. So that is also one circuit is there. We can construct that master and slave JK flip-flop with the help of this JK flip-flops. So JK flip-flop applications, coming to applications, these are used in counters, that means used in binary counters and frequency dividers, and used in shift registers, that means used for data storage and transfer systems. Toggle circuits, so most of the time we need toggling conditions, likewise works as a T flip-flop when J is equal to 1 and K is equal to 1. And control circuits used in control logic and state machines, and digital systems used in sequential circuits and memory elements. Coming to the summary, the JK flip-flop is a versatile sequential circuit element that overcomes the limitations of the SR flip-flop by eliminating invalid states. It supports multiple operations including toggling, making it highly useful in counters and control circuits. However, issues like the race around condition requires careful clock design. Overall, it is an essential component in modern digital systems. Thank you.